Hello, this video tutorial goes along with Unit 2, Section C1, Introduction to the Graphing Calculator, the TI-83 Graphing Calculator. Before we begin this investigation, we need to make sure that calculators are all starting out in the same place. To do this, we're going to reset the memory. Push second, and then the plus sign, which is mem. You're going to scroll down to number 7 to the reset. You can scroll down to number 7, or you can just push the number 7 on the keypad. Then you're going to clear all RAM. It's going to ask you if you want to reset, and you say yes, or you push enter on reset, and it'll show you this. RAM is cleared. And clear the screen, and we are back to the starting spot. The first key that we want to explore is this mode button. For our purposes, for just starting out, everything in the mode should be over here on the left. Similar in second format, everything over here for somebody starting out should be over on the left. Performing just calculations on your calculator is typed in almost exactly the same way that you see them. If you view question 1 on the Unit 2 C1 Introduction to Graphing Calculators from michiganmath.org, you'll see several problems. Something like the very first one, which states 3.9 minus 1.4 divided by 9 minus 6. To put this in your graphing calculator, you push it almost exactly the way you see it. What you don't see in a problem like this is parentheses around the top. When you see in a fraction bar that goes all the way across, it's telling you, assuming that there's parentheses at the top and bottom. So what you would do on your graphing calculator was make sure that you put those, because the graphing calculator only does lines. 3.9 minus 1.4 parenthesis right here divided by parenthesis 9 minus 6 parenthesis, and then there you have your graphing calculator answer. Now this answer is really easy to put into fractions as well. Say this is a slope, and if you were doing this, you might want it in fraction form, so it's easy to graph. You can push math, frac, enter, and you find out that this is equal to 5/6 when reduced. Other things include problems like we'll take one of the larger ones here. We'll take 5 times 2x minus 1 plus 7x equals 3 times parenthesis x plus 13. Suppose we wanted to solve that. We know methods to do this. You would first start by distributing, then adding like terms, getting all the x's on one side, all the numbers on the other, and then solving for x by dividing or multiplying. This is a pretty standard equation. If I would have put a log in here, then we might not have known what to do. Regardless, here's how we can solve this equation with just the calculator alone without any symbol manipulation. Here's what we could do. Push the y equals key, and that gives you these screens, commonly referred to as the y equals screen. Pick one side of this equation. We'll say this side right here, and we'll call this y1. And we'll call this side right here y2. We want to know where y1 equals y2. So this is what we'll do. We'll put it in our graphing calculator just the way we see it. 5 parenthesis 2, x is right here, right underneath mode, x minus 1 parenthesis plus 7x, and below that is 3 parentheses x plus 13 parenthesis. Once those two things are in, what you next do is go to table set, which is right above this word window. You have to push second, table set. And a good idea, and it's already there to default, is this table start at 0. So the first number on your table is going to be 0. And it's going to go in jumps of 1, which means it'll go from 0, 1, 2, 3, 4, down, and so forth. And we can go in the other direction, -1, -2, so forth. Now as far as these go, independent and dependent, choose auto for now. We'll talk about these later. But for this particular exercise, we're just going to stick with this. Table. Once we've set the table, we can just go right to table, which is above graph, and you can see you have an x, you have a y, and a y2. We want to find out where y1 equals y2. So how can we do that? Well, we just go down until we find out where it equals. Here it's -5, 12. Here's -5 where y2 is bigger than y1. Here y1 is bigger than y2. So it reasons that somewhere between 0 and 6, y1 will equal y2. Let's find out where that's at. Where does it come closest? 40, here at 3, where this is smaller and then this is bigger, but then this is bigger and this is smaller. So that means somewhere between 3 and 4 is our answer, where these two things equal. Go back to table set. Start at 3, and this time instead of going up in jumps of 1, we'll go in jumps of 0.1. And go back to table. Let's see if we can find out where is the closest they get. 46, 47. This is lower. This one's lower than this one, but this one's higher than this one. So I think it's between 3.1 and 3.2. Still not finding anything that's exactly. So go back to table set. 3.1. Have this go up instead of 0.1, 0.01. So now we're going up by the penny. And go from 3.1, 3.2, 3.3, so forth. And push table again. Let's see if we get something that's closer. What is the closest one here? 4. This one is lower than this one. This one is lower than this one. This one's still lower than this one. But this one is higher than this one. So somewhere between here and here, they're going to equal each other. You can do this to any degree of accuracy that you're looking for. We will take, oops, I forgot what that was, 3.14, clever number, and table set 3.14, and this time it'll be 0.001. We'll go up by the thousandths. See if we can get something that's exact. 3.41, so that's lower, but that's higher. And this, we can keep going on in this process and keep going on. But if you wanted to round at this point, well, you know that it's 3.142 or 3.143. If you're only rounding to the hundredths, your answer would be x equals 3.14.